Hey you guys, Geometry, Module 3, Topic 1, Lesson 2. And we're talking about how we can establish similarity situations with triangles and simplifying it really nicely down to 3 specific things. As a reminder, go back and watch our poster notes on how to get some quick wins on this process. I want to highlight some things out right out of the gate on page 459 is angle similarity theorem, side similarity theorem, and side angle side similarity theorem. Those are a lot like different theorems we learned in the past on congruence, but there's like a little twist. It revolves around making proportions of the sides and then checking if the proportions are the same. So in this lesson on this string of videos, we're going to establish the angle similarity criterion, the side similarity criterion, and the side angle side, abbreviated as AA, SSS, and SAS, and I can't believe my circle did that. Okay, let's talk about some review questions though. The first set of 3 ordered pairs form a triangle, and determine whether the second 3 corresponding ordered pairs form a similar triangle. So what we learned in the previous lesson is going to be applied here. And if you haven't watched those notes, page 447 through page 456, what we did specifically on page 456 was look at the coordinates. And so if I know that there's probably a correspondence from 2, 2 to 4, 4, from 4, 2 to 8, 4, and from 4, 4 to 8, 8, if I can show that there's like a relationship, a scale factor, again, keyword for us from one of the other video notes, if I can show there's a scale factor that is a change of the coordinate by a multiplication, and all coordinates are multiplied by the same number, then we have proportions. And we have similar triangles. In fact, why don't I do the math, and then I'll show you the math on Desmos, and you should practice on Desmos as well. So here's what I notice, that if I take the 2 and I multiply it by some scale factor, it's got to make 4. So 2k equals 4. And in essence, what we know from that problem is k should be the result of 4 divided by 2. The scale factor should be 2. So I'm just going to check. I'm going to use mental math to do that. 2 times 2 makes 4. That's good. 2 times 2 makes 4. So this one certainly follows where the x coordinate and the y coordinate are multiplied by 2, the same number that they're multiplied by, and then the resulting answer is what you get from multiplying 2 times 2 and the other 2 times 2. How about 4 times 2? Again, times 2 is a scale factor. That's the scale factor. So 4 times 2 makes 8. 2 times 2 makes 4. That one's in proportion. Last of all, let's just check. 4 times 2 makes 8. 4 times 2 makes 8. So I'm going to say yes. All ordered pairs, justifying. All x, y coordinates, 2 O's in the word coordinate, are scaled by the same k value. All right, let me just check that though. I'm going to go to Desmos. So opening up a new web page and going to desmos.com/calculator, the best graphing calculator source online. So let's see here. I want to make sure that the computer can handle all this processing. It's so much memory being used. 2, 2, and 4, 2, and 4, 4. Okay, so right underneath my picture, there is this, right here, there is this triangle where all of the coordinates of that triangle, you can see them if you imagine connecting the dots together. Let me do one more setting here. Much more improved. Okay, so then the question is, do the other dots form a similar triangle? I notice there's a right angle. I notice that the 2 sides are like the same length. You know, you've got 2 by 2. So I'm going to put in the other 3 coordinates and just to check visually that yes, the triangles are the same. And if you check visually, you could use tracing paper and then compare if the angles stay the same size. Because in similar figures, the angles stay the same size. Okay, so I'm going to type 4, 4. Which I've already typed, but I'm going to type it again for the second triangle. 8, 4, and 8, 8. All right, they're shifted up a little bit, so I'm going to kind of move the screen just a little here. Nope, other way. About like that. Okay, so I'm on here, that's on there. You can see that there's a little triangle over here in the bottom of the corner, and then there's a bigger triangle up above it. They are, in fact, similar triangles because the proportion of the sides is the same. The triangle is growing by double in the same way, and so therefore, yes, we have similar figures. Now, for that information, I'm not going to show this on question 2, although I probably should, but I do want to acknowledge find the K scale factor, and that video, I think it's number 2 in the sequence, is the one to watch to know how to practice doing that. So here goes, diving into it, going back to page 459. Okay, so what we need to do is we need able to take the first number, like the x coordinate, multiply it by an amount, and get the other x coordinate. So 2 from that point times k, because k is the scale factor, should result in 2/3. Solve for k. I'm going to divide by 2, divide by 2. I get these 2's canceling, so I get k equals 1. Something has to remain, and 3 on the bottom. I'm going to project that the scale factor is 1/3. So then I got to check it. I got to check, is 3 times 1/3 equal to 1? 3 times 1/3. Yes, the 3's would end up canceling, leaving us with 1/1. So that definitely works, where both coordinates are multiplied by 1/3 and we get the same size triangle. Let's go to the next one. 4/5 times 5. So 4 times 1/3. Yep, 4/3. 5 times 1/3. Yep, that works. How about 3 times 1/3? That does make 1. And 9 times 1/3, that also makes 3. So what we have here, in fact, is a second scenario where the scale factor, k equals 1/3, is going to take the first row of coordinates and scale them down. We have actually a shrink. Yes. Same reason, all x and y coordinates are multiplied or scaled by the same value. We end up with a shrink. Oh my gosh, there's an NK in there. And probably quote. And then over here, we're going to call this a stretch. Thank you for watching page 459. 460 is next. We're talking about establishing triangle similarity. Don't forget to like, comment, and subscribe, and I'll see you in the next episode.